Right. Okay. So in that equation you can see so in this the last one is V is equal to Ct cube, that is L by T by T cube is equal to C, therefore L T power minus 4 is equal to C. So this is the dimension formula for the constant C. Now let us see some dimension formulas for various physical quantities before going into further numerical problems. Let us see the dimension formulas for various physical quantities. Dimensional formulas for various physical quantities. So generally what is the dimension formula? If you give the power to any physical quantity, for example L is there, what is the power? 1. M is there, what is the power? 1. T, okay, T, power is 1. Like that you can change the powers also, that whatever power you are given, that is called as dimension. For example, sometimes T may be having minus 3, sometimes M may be having square, L may be having 0. This thing is called as dimension. That means power given to any physical quantity is called as dimension formula. For example, if you asked with velocity, velocity means rate of displacement, L by T, L T power minus 1. The same acceleration, for example, rate of change of velocity, L by T square, L T power minus 2. Force, F is equal to MA, that is ML T power minus 2. So like that you can write any physical work done, force into displacement, ML square T power minus 2 into L, that is ML square T power minus 2. So like this you can write down any dimension formula for any physical quantity. Okay. So this is how you will be defining dimension formula and various dimension formulas for physical quantities. Now what are the uses of dimension formulas? That is another important point in intermediate first year. What are the main uses? See, main uses of dimension formulas are to convert from one system to another system. That is the first thing, to convert from one system to another system. Second one is to check whether the formula is right or wrong. Okay. For example, you are given with some equation, say S is equal to ut plus half at square. Now by using dimensional method, we will check this formula whether it is right or wrong. See, for example, S is displacement, L, U, T, that is the first equation. Again, S is equal to half at square. Half is a constant, you can take it outside. Now we will check the first one. L is equal to U, L by T into T. So T cancel, L is equal to L. So it's the right formula. Secondly, this also you can check it. L is equal to half constant, acceleration means L by T square into T square. T cancel, L is equal to L. So this formula is correct. So like this you can check by using dimension analysis whether the formula is right or wrong. Whether the formula is right or wrong. Now what you will do is, by using these dimensional methods, we will check up whether the given, to convert from one system to another system. For example, we all know in intermediate derivation is there, 4 mass question, 1 Newton is equal to 10 power 5 dynes. So this proof you can do by using dimensional method. How? See, for example, let N1 into mk's unit of force is equal to N2 into cg's unit of force. These are the rules and regulations how to follow. The first step is let N1 into mk's unit of force is equal to N2 into cg's unit of force. Now what is force? Force dimension formula you know, M into A formula. So that is ML T power minus 2. Because whatever you are discussing here, force, in MK system the unit is newtons. In MK system it is newtons. And in CGS you will be measuring is dynes. You will measure in dynes. Now we will write a relation between this and this by using dimensional method. So for example here N1 into newtons. So what is dimension formula? So here I write as M1 L1 T power minus 1 and is m2 L2 T2 power minus 2. Now we'll interchange this one, m1 by m2 into L1 by L2 T1 by T2 power minus 2. Now here what will be coming? M2 L2 T2, M2 L2 T2. So here it will be coming N2 by N1. Now see here, M1 by M2, L1 by L2, T1 by T2 power minus 2 is equal to N2 by N1. Now what is M1 actually? M1 is the mass. In which system? MK system. See, I'll write it here. I'll write here. I think. See here, I'll write. What is M1? Mass in MK system. In MK system, it is measured in kilograms, 1 kg. By M2 means mass in CGS. It is measured in grams. So 1 kg by 1 gram into L1, mass, length in MK system. So it is measured in 1 meter by L2, again length in CGS, 1 centimeter into time, 1 second by 1 second power minus 2, that is equal to N2 by N1. Clear all of you? Now 1 kg means how many grams? 1000 grams. 1 kg means 1000 grams by 1 gram. Gram cut. 1 meter means how many centimeters? 100 centimeters by 1 cm. cm cut. Into 1 cancel, 1 you will be getting, that is N2 by N. How many zeros are there? 1, 2, 3, 4, 5. So 10 to the power of 5 is equal to N2 by N1, or 10 to the power of 5 N1 is equal to N2. Put it as equation 1. Now substitute this equation 2 in either top or in second equation. So what happens, we'll see. See here, we will substitute that equation in equation 1 or equation 2. So I will substitute here N1 into, this is Newtons, N1 into Newtons. What is N2 from here? 10 to the power of 5 N1. So what in the place of N2 I will write 10 to the power of 5 N1 into bracket lo dynes you are having. Now N1 cancel. What is left over? 1 Newton. So 1 Newton is equal to 10 to the power of 5 dynes. In intermediate, regular intermediate IPE, this is a 4 marks question derivation. 1 Newton is equal to 10 to the power of 5 dynes. Dyne is CGS unit of same force and Newton is MKs or SI unit of force. In the same way, you can find the relation for joule and erg also. 1 joule is equal to 10 to the power of 7 ergs, where joule is the SI unit of work done, erg is CGS unit of work done. Same process, if you go, you can derive this also. 1 joule you will be getting as 10 to the power of 7 ergs. Okay. So as I said just now, we can convert from one system to another. 1 Newton is equal to 10 power 5 dynes. In the same way, 1 joule is equal to 10 power 5, 10 to the power of 7 ergs. So like this, you can convert from one system to another system. అర్థమైంది కదా మీకు? ఇప్పుడు మనం ఏం చేద్దామంటే, so just now I told you what are the main, how to convert from one system to another system by using dimensional methods. Now what are the main uses, dimensional analysis? So main uses is from MKS to CGS, CGS to MKS, MKS to FPS, FPS to M. Like that you can change from systems and you can check the formula whether it is right or wrong. Okay. So not only these two, another point is also there, that is we can frame an equation. Third point, we can frame an equation by using dimensional methods. For example, we will see a small thing. We all know time period is equal to 2 pi into root over L by G for a simple pendulum. Here 2 pi is a constant, L is length, G is acceleration due to gravity, T is time period. For such problems, what you will get in exam is T proportional to L comma G. They will be giving like this. And you will be asking to frame an equation. And ఇలాంటిది terms ఇచ్చి మీకు physical quantities దీని ఈక్వేషన్ తయారు చేయమంటారు. How to prepare? See how the rules and regulations goes. First write the equation like this. T proportional to Lg. Second step, what you have to do is right side physical quantity, raise some powers. That is like A, B, C, D. P, Q, R, S like that. So L to the power of A, G to the power of B. Second step. First step, write the equation given T proportional to LG. Second one, raise the powers right side quantities, not left side, right side. Now write the third step, dimension and formulas for the physical quantity. Remove the proportionality because anyway you will get the value, constant value, that is K is 2 pi. Now L is length dimension formula A. G means nothing but acceleration due to gravity, that is L by T square. So L by T square to the power of B. This is third step. Now fourth step, you see how many physical quantities are there on right side and left side. If anything is absent in left side, create a physical quantity which is absent on the left side. Now here you can see left side only one is there. I can write as T power N, L power A, and this one I can write as L power B, T to the power of minus 2B. Now right side you are having two physical quantities, left side you are having only one. So create left side one more, that is by like this. Which is absent? L is absent. I can write L to the power of 0, T power 1, L to the power, this one I can add A plus B. Because bases are same, you can add the powers. L power A plus B into T power minus 2B. Now you can see L power 0, L power A plus B. So I can write as L power 0 is equal to L power A plus B. When bases are same, powers can be equated. Therefore, A plus B is equal to 0, A is equal to minus B. That is the first equation. Second one you can see here, T power 1 is equal to T power minus 2B, or minus 2B is equal to 1, B is equal to minus half. If B is minus half, what is A? A is equal to minus of B. Therefore, A is equal to minus of B, that is plus half. Now after getting the values A and B, put those values in this equation. See here, I will write it here. T is equal to constant value already told, 2 pi. L to the power of, what is A value? Half, plus half. Next, what is B value? Minus half. Now you can interchange this one by writing in this way, root L by root G. That is nothing but 2 pi into root over L by G. Therefore, time period of simple pendulum by using dimensional methods, you can obtain in this way, that is 2 pi into root over L by G. So this is how the third thing, the third use of dimensional methods. That is, first one is to checking the formula, whether the formula is right or wrong. And one more thing, you can frame an equation now. Okay? And you can change the systems from one system to MKS to CGS, CGS to MKS. So these are the things. Now, second last part in this units and dimensions, that is, okay, we will be learning about the second last one, that is significant figures. What are significant figures? And later on we will be studying about what are error analysis. So let us see what is a significant figure in this one. That is the second last topic to complete this chapter. Now what is significant figure? What is significant figure? See, I will give some values, from that we will locate what is significant figure. For example, 2.0, second one 2.010, third one 200, 20020. Now how to find significant figure? There are some rules and regulations. For example, we can see here, after decimal whatever digits are coming, those are significant. For example, here you can see 2.0 means you should not cut 0. You have to consider that 0. So in this case, the significant figure is 2, not 1. 2.0 means this, after decimal the digit is coming. So here the significant figure is 2. Now coming to second one. Here 2.010 means 0 you should not cancel. You have to consider all of the 4 digits. So 1, 2, 3, 4. So here the significant figure is 4. Now here you can see right side zeros are without decimals. Right side zeros are without. So here the significant figure is only 1 because no decimal is coming here. Only after the decimal only the significant figure are existing here. So here no decimal, therefore 1. In the same case here also no decimal, significant figure is 1. In the last one also you can see 20, significant figure is 1. So this is one case. Now let us go to second case in this one, significant figures. For example, if in the examination suppose you are given like this, 0.0003, 0.0003, 0.003, 0.03. Now here see, as just now I told you, after decimal figure is significant. In same way, in left side zeros, if decimal is there, it is called as non-significant. Same way, so here, how many are there? 1, 2, 3, 4 here. Still, even the point is here, the significant figure is only 1. You should not consider all this. Okay? In the same way here, 1. Here also, 1. Here also, 1. That means, left side zeros are non-significant again. Even though, how many zeros are there? You may be having 1 lakh or 1 crore. Left side is non-significant. You have to consider only 1. And here, in this case, right side, after 2.01 or 2.013, whatever the value is given, it is significant. And here you can see 2000 is given, 2000. So here should not write 4 as significant figure because no decimal is there. Without decimal it is non-significant. You can write only 1 only. The same way for 200, 1, 21. Now last case we will be dealing, that is exponential notation after this one. Last case, that is exponents. For example, you are given like this, 2.0 into 10 power minus 3. When 2.0 10 power minus 3 is given, here how we will write significant? Same way, 2.0, see after decimal 0 is coming means it is existing significant. So here the significant figure is 2. Here the significant figure is 2. Okay? For example, 2.01 10 power minus 4 or minus 6, whatever given. 2.01 is given. So, still decimal is there. Therefore, here you can write significant figure as 3. Okay? So, like this, in exponential form also you can write down the significant figure, or in normal form, zeros on the left side of the given digits or zeros on the right side. So, this is how the significant figures are identified for exponential notation and in normal form. Clear? So here one thing is very clear. Suppose if he gives like this, then what is significant figure? Here no decimal is there. So you can see only 1 is significant figure. 1. 20 into 10 power minus 4, 1. The same way if you are given like this, zeros are no decimals before. So, again 1. Because you can write this one in the normal form also. See, this one I can write is normal form like this, 20 by 1, 2, 3, 4. So, where the decimal will come? 1, say like this, see. 1, 2, 3, 4. 1, 2, 1, 2, 3, 4. So, decimal is coming here. So, what is the value here? So, after left side also if it is coming the zeros, the significant figure is taken as only 1. So, in exponential form and normal forms, significant figures are identified in this way. Clear? Right. Last one, last topic, error analysis. So as I said, only 1 mark is coming in MCET. Intermediate also I think maximum 1 to 2 marks. Last point in this one is error analysis. Error analysis. So errors, generally why errors are occurring in laboratory of physics or in chemistry, that means errors may be many types. Systemic errors, that means from the manufacturer defect, that means when it comes from the industry, for example like vernier calipers or screw gauge, the defect will be in itself inherent, that is called as systemic errors. Another type of error is errors done by human beings, that is in the laboratory when the student is performing linear caliper screw gauge, due to improper marking values, you will be getting errors. Okay? Like that you can identify the errors, but mainly in intermediate, in examination, errors will be in this type. You can see, for example, a rectangle is given for you. L and B are the length and breadth of a rectangle. He will be asking you, what is error in finding the area of the rectangle? What is error in finding of the area? What is area? A is equal to L into B. So if I take logarithms on both sides, log A is equal to log A plus log B. Finding the derivative, okay, delta B. So for that, if you find derivative, you will get 1 by A into delta A, 1 by L into delta L, 1 by B into delta L. So this is called as relative error. Now what all I have written here, delta A by A, delta L by L, delta B by B, this is called as relative error. Change in area by original area, change in length by original length, change in breadth by original breadth. Now how to get percentage error? Multiply with 100. Multiply with 100. So finally, what is the relative, percentage error in finding the area of the rectangle? So area is nothing but delta L by L plus delta B by B into 100. This is how we will find the, error in finding the area of a rectangle. In the same way, density, anything you can find out. For all the things, the formula is common. Okay? That is delta A by A means area. In the same way for density, delta D by D. Percentage means multiply with 100. For example, a small numerical will do for regarding this one. Then you can understand better. For example, in the examination you are given with length as 3 centimeters, breadth as 2 cm. Delta L is given as, for example, 0.2 cm. Delta B is given as for example, say, same value you can take delta B also, 0.2 cm. Now, for this, find the percentage error of the finding the area of a rectangle. Percentage means same formula here, you can see, delta A by A into 100 is equal to delta L by L into 100 plus delta B by B into 100. So delta L means change in length. What is the length? 0.2 cm by L, 3 centimeters into 100. Delta B, for example, same thing I have given 2 cm by B, how much? 2 cm into 100. cm cancel. 0.2 by 0.3, that means 2 by 30 into 100 plus same here 0.0, that is 2 by 20 into 100. Now suppose if you roughly find how much is 20 by 3 means 3 6 is 18, okay, 20 by 3, 3 6 is 18, 2, that means again 6.66 this one. The same way this one, how much you will get? 25 and 5 to the 10. So roughly how much you will get? 10 plus this means 16.66% roughly. So like this you have to calculate error analysis in finding out area of rectangle or anything given. The main formula, basic formula is this thing. It may be density or area. Okay. So here you can see, check it whether it's right around 25 and 5 to the 10. Okay. So 10 plus this one how much? 3, 6, 6 point, that means 16 point. This is the error, percentage error in finding the area of the rectangle. Like this you can solve any problems. Okay. Right. See, that is one type of error analysis. In examination, MCET or normal exam, sometimes he may ask in this form also. For example, volume of a sphere. For example, solid sphere volume. You can take it as 4 by 3rd pi r cube, volume. So sometimes he may ask, what is the percentage error in finding the volume of a sphere? So that way you can calculate, see volume means 4/3 pi r cube. Here you can write like this, delta V by V. All these are constants, 4 by 3 pi. So take it outside here, r cube I can write as 3 into delta r by r, another simple method trick. Okay, This one is constant. R cube I can write is 3 delta R by R. So 3 delta R by R is equal delta R by R is equal to delta V by V. Now percentage, this is relative error. Percentage error means how much you will get? Delta V by V into 100 is equal to 3 into delta R by R into 100. That implies, see, 3 times the percentage error in radius is equal to 1 time the percentage in volume. That means, if suppose you will get, see, for example, volume percentage is 1%, say. The change in volume percentage is 1%. So how much it will be now? Suppose this is 1%. This is 3 times. 3 into delta R by. This is 3 times the radius change. So like this also you can solve very fastly the numericals in error analysis. Anything, either it's volume, area, but you have to apply this formula for, please make a note, this formula is only valid when the error is 1%, 2%, 3%, up to 5% only, please. These technique formulas you have to apply only for the error when it is up to 5%. More than 5% if it is given like 6%, 10%, then this may go wrong. Then you have to go normal method. That is delta A by A is equal to delta L by L into 100, delta B by 100, okay, delta by B into 100, like that you have to go. Logarithmic method. You should not apply this method because this method fails when the error increases more than 5%. Okay, so please make a note. So in this chapter in MCET you will get hardly 1 to 2 marks. In intermediate also, sometimes you will be giving derivations. As I said, 1 Newton is equal to 10 power 5 newtons. 1 Newton is equal to 10 power 5 dynes. In the same way, 1 joule is equal to 10 to the power of 7 ergs, the relation between. And also to frame the equation also you may be asking in intermediate IP, regular intermediate. So these are the main questions in dimension analysis, fundamental quantities, derived quantities, error analysis, significant figures, etc. etc. So this is end of the first chapter, units and dimensions. In next chapter we will be meeting with elements of vectors.